We have three main programs. We have community teams, we have resiliency hubs, and then we have a climate prep week. So first of all, I'm going to talk about our community teams. Basically, what are community teams? Community teams are a group of 3 to 5 people. If you have like in your neighborhood, you are able to gather 3 to 5 or more than those people. You can gather those people, and you can think about how your community is like vulnerable to extreme weather, like in your city, in your town. Then as a crew, we're going to provide you support, necessary information like flyers, like how can you be more resilient toward extreme weathers. So in this picture, you can see our crew team, which is the right picture is a picture where our crew team at Somerville is busy in doing the de-paving. Like if you think you have a space which is like cemented or paved for a long time and you don't need that, and you might think that you need a green space, so we can do that for you, de-paving, and this way you have more green area, good for environment. And then on the left side, there are some folks from our crew teams who are discussing uh, uh, how they can contribute within the community, how they can go into their community and talk about climate resiliency, how communities can be prepared for extreme weather events, like what if there will be a storm, how they can help each other, how they can prepare a medical kit, how they can go into a resiliency hubs. So this is our one program, which is called Community Team. I'm going to go into the next slide, which is about the resiliency hubs. Resiliency hubs are basically community institutions. They might be a local business, nonprofit, libraries, churches, schools, and others. And being a resiliency hub, you have to commit it to provide any assistance to the community within your local area before, during, and after extreme weather events. So if you are a part of an organization, or you have a space which you can think might be a potential resiliency hub, which can be used for the community in case of any extreme weather. Let's suppose there is a flood or storm, you can provide your space as a shelter, or people can come in during the emergencies to charge their cell phones. Or if there is a heat wave and the community is out of power, people can come into your like facility, and then they can you can provide them like heating and cooling as well. So this is the concept of our resiliency hubs. And uh, what does it take to be a resiliency hub? So we want our resiliency hubs to display a climate resilience hub window decale, make a climate emergency preparedness information session, and host a yearly or more frequent climate preparedness events in their facility. So we have like 3 different levels for climate resiliency hubs. You can provide your institution or your organization building as a shelter during the heat waves, as a shelter during the storms. So also we are thinking, we thought this might be a good start if you, although there are like government organizations who have like resiliency hubs, who have like shelters, but as a crew, we are building those resiliency hubs within the grassroots levels, within like we want to do this in each community. So people, let's suppose in case of like flood, people don't have to travel a lot to be into a resiliency hub. So that's the background for resiliency hub. And here's a map for our resiliency hub. If you go into our website, Climate Crew, you can see like there are like you can see easily we have resiliency hub map, and you can find out which are like close by resiliency hubs. Till now we have like 15 around, and we are in process to expand them, and people are showing interest in them. And last but not the least, our last program, which is about the climate prep week. Every year we have like a climate prep week from September 24th to 30th, where we have events dedicated to learning services and actions. they'd better prepare our communities for extreme weather events. Actually, the basic aim of this is by coming together, we can host events. We provide the resources as a crew. We can provide the resources if you want to be part of this event. We can provide you the resources and space to think about how we can bring our communities to more and more resiliency. And last year we have around 134 events. Like you can be part of this program. Either you can host an event at your organization, or you can be part of you can be a partner of our main event. So for Climate Prep Week 2020, we have already scheduled a lot of events. You can see the blue ones who are hosting some events, and the orange one are like partners with our main events. So so how you gonna be part of our programs? If you are interested and want to be part of like our programs, you can do that by signing up into our sorry, my screen share is gone. So you can sign up to our newsletter. You can start a crew team in your neighborhood. Like if you think you can gather 3 to 5 person in your community, you can you can start a community a crew team. Or if you have already a crew team in your neighborhood, in your town, you can be part of that one. And and the last thing is, if you are part of an organization, any faith community or any other organization, you can be a resiliency hub. And if you know anyone who is interested to become a resiliency hub to help our communities, we can do that as well. So one of my colleague, Ethan, will share our link. So if you want to be part of our programs, please do write us, and in that way you're gonna be part of us. So now we're gonna go into the next phase of our event. So in the next phase, we have really interesting talks from our panelists. First of all, I'm gonna invite Professor Paul Kirshen, who is a professor of climate adaptation at UMass, and he worked a lot around the Climate Ready Boston and other projects for climate resiliency within the Boston and Massachusetts area. So I'm gonna invite Professor Paul Kirshen for the talk. And if you have any question, just write your questions in the chat box. And at the end of our discussion, we're gonna ask your questions from the panelists. Well, thanks a lot. Professor Paul, floor is yours.
Okay, thank you very much. It's a pleasure to be here this evening, and I thank you for taking the time to participate in this. As you know, climate change is a major threat we're facing, and sort of all hands on deck in trying to deal with it. I'm going to go on mute. I'm going to go stop my video and share my screen. And let's see, these work. Okay, so you should see my screen which says climate change in Metro Boston. Is that correct?
Yeah.
Okay, so I'm going to run through the next, 5 or 10 minutes, some of the climate change threats we're going to see in Eastern Massachusetts. I want to point out that this is work that was done about 4 or 5 years ago for Climate Ready Boston, but right now we're updating this. And the updated climate projections are not only going to include Boston, but also all the MAPC plain area. So essentially all the communities within Route 495. And that report will be ready by the end of this year. Okay, so let me just go ahead here. Okay, so climate change is caused by the greenhouse effect, essentially because we're putting up this layer of gas in the atmosphere, so-called greenhouse gases, which come about because the burning of fossil fuels. We're reflecting back more heat than normal. So actually heating up the earth. And you look here on the right, You can see surface temperature changes from early in the century to present, and the darker color means higher temperature change. So pretty much globally, there's been an increase in our surface temperatures, particularly at the polar regions. And, you know, climate change is more than just about heating up the earth, because it's also about actually changing many of the other aspects of our climate. And, you know, here we're talking about watersheds. One of the major changes is going to be on the hydrologic cycle. And hydrologic cycle essentially is the whole process of evaporation, cloud formation, runoff, rain formation, then runoff, and also recharge to groundwater. And essentially, under climate change, you know, we have evaporation from water and from land. Because it's warmer, we have more evaporation, evapotranspiration in the past. And so with more moisture going up, obviously we have to have more moisture coming down in terms of rainfall. And then with more rainfall, we get some of that water soaks into the ground and recharges the groundwater. Some of it flows across the surface as stream flow. But as I said earlier, the major signal is the increase in the rainfall. So this shows the global increases in rainfall. Here is, this is by the trend, millimeters per year. So I just look over, you know, beginning of the century to the present, essentially, pretty much through large portions of the Earth's atmosphere, the large portion of the Earth, we've seen increases in mean annual rainfall. The distribution is unequal. Unfortunately, in the mid-latitudes area, we've seen increase in mean annual rainfall. Around the tropics, though, where unfortunately many of the people in the developing world live, there's been a decrease or no change in mean annual rainfall. This just shows the trend between 1951 and roughly the present, and you can see this increase in rainfall has essentially accelerated, like all aspects of climate change. They've accelerated in the last 50 or 60 years or so. So again, because of climate change, we're speeding up global evapotranspiration, and globally we've seen an increase in annual rainfall that's not evenly distributed across the Earth. And then another major change is sea level rise. And sea level rise is essentially caused by three major factors. One is obviously as the ocean warms, it expands, takes up more volume, and sea level goes up. And then the other one is the melting of ice on land. This is increasing the volume of water in the ocean. And of course, the volume of water increases and sea level goes up. This does not include ice that's melted, let's say from the North Pole, because that ice is already in the water. So I'm sure you've all heard about the threats from the melting of the ice sheets in Antarctica and Greenland. They're very real, and they are going to also cause our sea level rise. In fact, you know, initially in the last couple of decades, most of our sea level rise has been because of thermal expansion of the ocean. But in the last couple of years, it's now because of melting of this ice on land. And then these cause global increases in sea level rise. What happens in our local sea level rise is mainly because of local subsidence of the land. Land is sinking. It's unrelated to climate change. So in the Northeast here, our land is sinking more than other places. So our relative sea level rise is going up. Also, our relative sea level rise is going up because of regional factors related to global circulation. So roughly in the last 100 years, we've seen about a foot increase in sea level rise in Boston, 6 inches because of global factors, thermal expansion, melting of ice on land, and the other 6 inches over the last century because of subsidence of the land. And so this shows here that again, over the last 2,500 years, we've seen a rapid acceleration in sea level rise. And so what does this mean locally? So in 2015, City of Boston did their Climate Ready Boston study. In order to do that study, they need to have projections of these four factors. And there's many projections of these four factors. They needed one set they could work from. So they went to UMass, put together a team of all the scientists in Metro Boston, the universities around here, from LU, Mass Boston campuses, and we put together consensus projections of these four climate change threats. And I led this study along with my good friend and colleague, Ellen Douglas. So for several rise, right? So again, these are changes since 2000. A couple of things to take from this. One is, end of the century, it could be 2.5 feet to 7.5 feet of relative sea level rise. But more generally, what this shows is there's a range in these projections, and the range increases over time. Why is there a range in these projections? That's because we don't know exactly how much sea level rise we're going to see, how much climate change and sea level rise we're going to see in the future. And there are two reasons for this uncertainty. One, as I said earlier, is that climate change is because of our emissions of greenhouse gases. We don't exactly know what's going to be the future emissions of greenhouse gases. A couple of years ago with the climate accords from Paris, we were quite hopeful we might get them under control. But in the last couple of years, that's no longer the case, and they've been growing. So depending upon our greenhouse gas emissions, directly influences the amount of climate change we're going to see. So it's an uncertain phenomena. So this is a scenario. The other source of uncertainty is while we have a really good understanding of the climate system, it's not perfect. And so we still have uncertainties in what's the impact of pumping up our atmosphere with certain amounts of greenhouse gases. So you can deal with this range of projections. And the range, as you can see, the range of uncertainty grows over time. And so this is sea level rise. This is number of hot days. So right now we have 11 days a year, over 9 degrees Fahrenheit. By the end of the century, it could be 25 to 90 days. It's 90 days, actually 3 months. It would mean like every day of the summer is greater than 9 degrees Fahrenheit. And then extreme precipitation. This just shows changes in the so-called 24-hour 10-year storm. So right now it's over 5 inches. When I was in graduate school in the 70s and so, this value was 4.2 inches. So just over this period, we've seen this estimate change from 4 to 5 inches. And then it could increase again, depend upon our emissions of greenhouse gases up to 6.5 or just about 6. So again, we have all these changes in these major drivers. And so what are some of the implications of these? So one is we're just going to have increased street flooding. So every one of these dots shows a manhole that would flood in Metro Boston under the present amount of rainfall. So if the rainfall goes up, obviously more flooding. And then this just shows sources of non-point source pollution in Boston. These are all going to increase under climate change with more rainfall. You notice there's an area in Boston where it's sort of tan off to the right. There's an area where there's combined sewer systems, and a lot of the runoff here goes into the system that's treated by Dyer Island. The rest of the system off to the left here is just separated systems where if it rains, that water goes right into receiving waters. And then this is a fairly complicated diagram. This just shows possible changes in peak flows in the Charles River over time for the spring season and the fall season. So for example, right now, the 100-year flood in the spring season in the Charles River is about 8,800 CFS. Under a low emission scenario, it could be 10,000 by 2070 or 12,000 by 2070 under high emission scenario. There's an increase of about 50%. So major impacts of flooding. And this just shows coastal flooding. This shows the present coastal flooding in Boston Harbor under various frequency of storms. So the largest extent of this is the so-called, in fact, is stuff that's like 1,000-year storm. But essentially, and then this over here shows the growth of this. If you had 5 feet of sea-level rise, which is certainly possible by end of the century. So you see significant changes in these floodplains between now and possibly 2070. And you know, we've already seen major flooding in Boston, so it's going to grow. And then I know I'm running out of time. This just shows what many of the residents in Metro Boston are concerned about in terms of climate change impacts. And in blue are the impacts. So you can see they're mainly concerned about sea-level rise, storms, flooding, and temperature. But they're also concerned about air quality, erosion, surface water flooding, droughts, and so on. So there's a lot of concern about these impacts. And then how much time do I have left? Do I have any time left?
3 more minutes.
3 more minutes, okay. So I just want to close by, you know, what can we do about trying to manage these impacts? And the other participants, the other speakers are going to be talking about some localized impacts. But in general, these are some of the ways we can think about trying to adjust to these impacts. First of all, most important is to control, lower the emission of greenhouse gases because they're causing the problem. But even if all the emissions of greenhouse gases went to zero today, we're still going to have climate change for centuries because of the inertia of the climate system in the oceans. So we as humans, and we have to adjust or adapt to these changes, the process of adaptation. So how do we do that? Well, first thing we think about is, you know, what's a range of future conditions of climate change? And what are scenarios? You know, again, a scenario might be 2.5 feet of sea-level rise by end of the century, or 7 feet of sea-level rise by end of the century. We need to consider this range of futures. And then we have to think about solutions that work well over this range. Whether we have 2.5 feet of sea-level rise or 7.5 feet of sea-level rise. What's a solution that'll let us manage that amount of sea-level rise? And oftentimes think about solutions that are flexible or adjustable. So we think about solutions, let's say for coastal flooding. Simple case example is you might build a seawall or a nature-based solution that can handle 3 feet of sea-level rise, but designed to be expanded to handle 7 feet if 7 feet was to occur. So we think about solutions that are mainly flexible and adjustable. And also we think about solutions that have no regrets. So they make sense to do now if there wasn't climate change. Also, we think about solutions that have co-benefits that not only control flooding, but also if they're nature-based solution, it might create green space. It might create pathways. They have other benefits besides their primary purpose. And then, you know, climate change is not the only threat we have to sustainability. We have to integrate with other kinds of issues, like you know, population growth, land use change, global instability. And then we have to recognize in adaptation that there's all sorts of adaptive capacity issues. You know, we all have different resources to adjust to climate change. That's going to be thought about. And of course, to realize the issue of marginalized populations don't have the resources of wealthier populations. They're going to face deeper and more profound stresses from climate change. We have to recognize that. You know, the wealthy can essentially buy their way out of climate change. Marginalized populations are not going to have that opportunity. And this is true in the United States, obviously, as well as true globally. Then also, you know, climate change adaptation has to be evaluated with multiple criteria, not only cost, but also environmental and social impacts. And then adaptation is local, stakeholder driven. And then lastly, you know, if you build something today on the coast, or anywhere. Obviously, we want to make it climate change resilient. But we also have to worry about how to protect our existing infrastructure, our existing vulnerable populations. And there's a process, it has to be considered also. That's a process I call prepare and monitor. So thank you for your time. And I look forward to this discussion. And thank you very much again.
Thank you, Professor Paul, to walk us through what is climate change for Boston and Massachusetts. We have some questions for you, but we're gonna ask those questions in our Q&A session at the end of this presentation phase. So without waiting, we're gonna go to our next presenter, who is Dr. Danielle Perry. Dr. Danielle Perry is Mass Audubon Statewide Climate Change Adaptation Ecologist. She's actually working to improve the resiliency of Mass Audubon sanctuaries to climate change impacts. And in this position, she is evaluating the vulnerability of Mass Audubon sanctuaries to climate change and extreme weathers, and implementing climate change adaptation projects to improve resiliency of these environments. Dr. Danielle Perry is responsible for developing external partnership with towns, nonprofits, and other environmental agencies to enhance resiliency of Massachusetts land and resources. And Dr. Danielle Perry actually received her PhD in biological and environmental sciences from University of Rhode Island, and her dissertation was on improving the resiliency of wetlands to climate change impacts. So we're gonna listen to our next speaker, Dr. Danielle Perry. Floor is yours.
Thank you for that introduction, and thank you everyone for joining this evening. Okay, can you see my screen okay?
Yeah.
Okay, wonderful. So today I'll be talking to you a little bit more about some of the climate change adaptation work that Mass Audubon is implementing and will be implementing in the future. So Professor Paul did a great introduction of what climate change is, what is causing climate change, and one of those impacts of climate change that he mentioned was sea level rise. And I'm focusing on our coastal communities within Mass Audubon and our coastal wildlife sanctuaries. And one of the greatest impacts that those sanctuaries, as well as our Massachusetts coastline, will be facing is sea level rise. And that is due to the fact that within New England, we do see rates that are about 3 to 4 times greater than the global average. And that is due to the low-lying areas within this region. And some of the impacts of sea level rise is coastal flooding, damage to our infrastructure, changes in habitat type, as well as loss of coastal and wildlife habitat. So what we're working on in Mass Audubon is ways to mitigate some of these effects in order to enhance resilience, to make sure that we are strengthening our sanctuaries as well as our Massachusetts properties as climate change progresses and sea level rise increases. So the first step is for Mass Audubon is completing these vulnerability assessments of our sanctuaries, and that's starting with our coastal sites. And the first step of our coastal vulnerability assessments is the sea level rise assessment, where we're looking at current models and projections of sea level rise that is published by NOAA using the NOAA Sea Level Rise Viewer and the data collected and portrayed within that viewer, as well as this model called Sea Level Affecting Marshes model to get a better idea of how sea level rise will be impacting our salt marshes and our neighboring infrastructure and coastal infrastructure. And what are some avenues of habitat migration for salt marshes as well as for other habitats. So as I mentioned, that we are using NOAA Sea Level Viewer data and NOAA Sea Level Rise projection data to analyze how our sanctuaries will be impacted by sea level rise. And this is just a photo of Allen's Pond Wildlife Sanctuary. And I'm just gonna walk through time with me as I kind of show how sea level rise is expected to impact this habitat and the sanctuary as over time. So this is just what current scenario as of right now is this intermediate high scenario of about 6.36 feet by 2100. And as we go to 2040, we do see an increase in the mean high tide line. We're seeing greater depths within what used to be land habitat and our pond water expanding. 2060, again, we're seeing more increase in flooding within this habitat. 2080 and 2100. So not to say that to be a downer for this sanctuary, but really to get a better idea of what is expected in the future and what can we do to mitigate some of those impacts, and what type of climate adaptation actions can we put in place so we're not seeing these large effects of sea level rise and potential losses to our important wildlife sanctuaries and habitats. So after analyzing the sea level rise scenarios and how that's expected to impact our infrastructure as well as our habitats within our sanctuaries, we then will have meetings with our ecological management team and our sanctuary staff to then begin to prioritize and score the different resources at our sites, to then get a better idea of where we should start, how we should be prioritizing our actions when we are talking about climate adaptation work. And then I'll be completing field surveys of the salt marshes within our coastal sanctuaries to then get a better idea of what are the current conditions of our salt marsh sites and how resilient are they currently to sea level rise, and how resilient will they be in the future? Because are they already showing signs of degradation? Are they currently showing signs of strength? How can we emphasize those strengths and enhance those strengths to further combat sea level rise and climate change? So getting a better idea of what the current conditions are to inform our future actions. And then lastly, developing these climate change adaptation projects for our sanctuaries based off of that prioritization list that we discussed with our sanctuary directors and with our ecological management team. So we're making sure that we're approaching the sanctuaries first that are most vulnerable to climate change and most vulnerable to sea level rise. And how Mass Audubon pictures climate change adaptation is really focusing on nature-based solutions. It's being inspired by this system of nature-based solutions of using natural systems and natural practices within those systems to help us mitigate climate change effects and help us slow down those negative impacts that we would see otherwise, and to better protect our coastal areas as well as our coastal infrastructure. So this is often an example of nature-based solutions, can be green infrastructure and low impact development. And just examples would be like rain gardens and permeable pavements and roof gardens and green roofs as well. But really for my position, the nature-based solutions I focus on are for habitat management and best ways to preserve our habitats and enhance the resiliency of our habitats. And that can be looked at in a number of different ways. So one avenue is when we're looking at our forests is that we want to be able to diversify the communities within our forests, because with diversity, it enhances resilience. So we want to be able to plant a diverse amount of trees. We want to be able so that these climate change effects will not be as strong with this enhanced diversity of our forest environments. And for our wetlands, where we can, we want to remove, when we're appropriate, removing dam structures, removing impoundment in culverts in order to enhance wetland health as well as stream health. We had a project at Tidmarsh Wildlife Sanctuary in Plymouth where we actually did a stream connectivity and stream restoration project in order to promote healthy streams and the wildlife that are associated with those habitats, as well as with our salt marshes. So this is a picture on the bottom here of what's called a dredged channel that is actually used to drain pockets of ponded water on our high marsh, salt marsh areas draining that ponded water that is settling on the marsh due to sea level rise and that is not draining after high tide, that is actually drowning our vegetation. And we're losing important habitat for salt marsh sparrow, which is a declining bird species, as well as other wildlife. So wanting to do mechanisms of these channels of draining those excess pools in order to promote vegetation growth and to preserve that important habitat within our salt marshes. And this is a technique that we'll be implementing at, or plans to implement at Allen's Pond, that picture that I showed of the NOAA sea level rise unit of that wildlife sanctuary. And also for dunes and for beaches, being able to do dune plantings to stabilize our dune ecosystems in order to enhance that coastal resilience and to stabilize our coastline. And this is a project that we are exploring for our Nantucket sanctuaries currently, and also to preserve that important habitat for our piping plover, which is another threatened bird species within Massachusetts. And we don't want our work just to be impacted by Mass Audubon sanctuaries. We also want our work to affect Mass Audubon properties as a whole. And by doing that, we want to collaborate, and we're collaborating with our municipal vulnerability preparedness communities and towns that are doing planning, with climate resiliency planning for their municipalities, whether that be protection for infrastructure, protection for natural habitats. So we're collaborating with these towns on climate change adaptation and having the results of our vulnerability assessments and relating them back to the priority actions that are listed within these MVP plans. So we're not only addressing climate vulnerability and climate resilience for Mass Audubon sanctuaries, but also for Mass Audubon properties and municipality resources. So the MVP program, they are able to apply for state funding for these action grants, where they're able to do climate resiliency work, and they're able to either enhance their infrastructure if that's listed as some of their priority actions, or making sure that they're enhancing their natural systems. So they're able to develop a proposal for one of those topics, and Mass Audubon often collaborates them on these proposals and helps them to enhance climate resiliency, depending on their priority actions that they're listing in their proposal, as well as their MVP plans. So just an example of an action grant from the MVP process is a living shoreline visibility. And so living shorelines are another example of a nature-based solution to stabilize our shoreline, to enhance coastal stabilization, and also to provide habitat for some aquaculture species like oysters and other shellfish. And also to restore our barrier beaches and in our dunes, so again, to enhance that coastal resilience. Another example is another project that occurred of purchasing land for conservation. So making sure that we're connecting our lands in order to enhance resilience, to add another, to further enhance against climate change effects, and being able to preserve these ecosystems and making sure that they're connected to further enhancement of climate resiliency. So some future project that Mass Audubon is working on, and one of the projects that I'll be working on moving forward, is these phenological studies of where we're actually reporting seasonal patterns that are, whether that be when are our flowers blooming, when are our birds migrating, when are our birds nesting, and when our animals are laying their eggs. And so taking record of those seasonal patterns, so then we can start tying that into climate change effects, and how is that changing over time, and how is that changing with climate change. And this is one avenue that we want to engage our community to help with these types of surveys of these seasonal patterns, to then start building this database that we can look back on over a number of years, so we can see how exactly climate change was impacting these different factors of our vegetation and of our animal behavior. And with that, I think we'll do questions at the end, but looking forward to your questions then. I think you're muted, Gufran.
Thank you, Dr. Danielle Perry, for the interesting talk. We do have some questions, but we're gonna cover those questions at the end of the discussion. So without waiting more, we're gonna go for our next panelist. We have Julie Dyer. She is Deputy Director at Charles River Watershed Association. Julie works closely with the Executive Director and staff to continue the great work of Charles River Watershed Association and to take on many issues the river and watershed residents face as we confront a changing climate. As a part of her job, Julie also oversees Charles River Watershed Association science program, which includes climate change adaptation, uh, Blue Cities, field science, and education programs. Julie provides support for Charles River Watershed Association advocacy work, analyzing Charles River Watershed research and data to inform organizational focus and reviewing projects. Julie has a BA in mathematics from Boston College and an MS in environmental sciences from University of Massachusetts, Boston. So we're gonna listen to Julie, and she's gonna talk about the case study from Charles River. So floor is yours, Julie.
Great. Thank you so much, Gufran, and thank you, Dr. Paul and Dr. Danielle. Great talks before me. I think will allow me to go rather quickly through my through my talk. You guys really set things up very well, and then of course thank you to all of you for joining us tonight. So I'm going to talk about us at Charles River Watershed Association, the Charles River, and what we're doing to take on the challenge of climate change. So Charles River Watershed Association has been around for a while. We're one of the oldest watershed associations in the country, actually. And of course, however, I should note that the human impacts to the Charles date back much further. There's, evidence of many native populations using the Charles River for travel, for fishing, sustenance. So the Charles River has been culturally important to many civilizations as it is to ours locally today. As Gufran mentioned, we have a few different programs, monitoring, stormwater, climate adaptation, and advocacy, working in a bunch of different fronts and various strategies to improve the health of the river. So everyone lives in a watershed. Hopefully you all know which watershed you live in. If you don't, make sure you look it up after we get off, or if you're at your computer, you can look it up right now. So in the Charles watershed, the river runs from Hopkinton to Boston Harbor. And much like the Boston Marathon, which also runs from Hopkinton to Boston, however, the Charles takes 80 miles to do it versus the 26 miles of the marathon route, because it is a very windy river, and our understanding is that actually the native name for the Charles River meant the river that winds back on itself. So just a little spotlight on the Charles and where we are, one of 3 rivers that flows into Boston Harbor. And my colleague from MyRWA will be talking about the Mystic, which also flows into the harbor shortly. So Dr. Paul did a great summary of climate change and what to expect. Lots of resources out there, both from the Climate Ready Boston that was already mentioned, as well as from the state's MVP mentioned that Dr. Danielle talked about. So we work a lot with the 35 communities within our watershed, and both try to support what they're doing and also try to help them move forward with some of the solutions that we've identified. So what do we hear from our local community as far as what their concerns are from environmental changes? It's primarily issues around rainfall, heat, intense storms and winds, and drought. many of our communities do rely on local groundwater supplies. Of course, that's outside the urban Boston area where we're getting water from the central part of the state from MWRA. In the upper parts of the watershed, they are relying on local groundwater. So when we're in a drought, as we are right now, they really can get hit pretty hard by that. And as Dr. Danielle summarized in the, as far as the approach that Audubon is taking, we also really look to nature to find a lot of the best ways to adapt. So building climate resilience is a great opportunity. As much of a challenge as it is, we do see it as a great opportunity to build a healthier world for people, all people, and our rivers and our natural systems. And a lot of the ways that we can do that are really just learning from nature. So nature has a lot of adaptation techniques built in, and how can we bring those back into our landscape? How can we re-engineer our landscape to help us accommodate? Many folks have maybe seen some slight version of the cartoon image that I have on this slide here, showing our developed landscape versus our natural landscape. In a natural landscape, when it rains, about 50% of the water would go down into the ground. In a developed landscape, it's only 15%. So obviously that's causing a lot of exacerbating a lot of issues around flooding, and it also is causing some challenges for groundwater supply, both for human use as well as for our natural systems, because where do rivers get their water when it's not raining? From the groundwater. So it's really important to our natural systems. So this is just a summary slide of Charles River Watershed Association's Adaptation and Resilience Program. We take a lot of different tacks, both with our, through our monitoring program, through our climate adaptation and resilience on the ground restoration programs, and our advocacy programs. Really much of our work focuses on how can we build resilience to climate change. So I'm just going to talk about a few different project examples that we have at a few different scales, and then I'll hand it over to Melanie and also be happy to take more questions. So one way that we work, similar to what Dr. Danielle mentioned, is we work with a lot of our communities and partner with our communities. A lot of our communities also participate in the Municipal Vulnerability Preparedness Program that was mentioned, where they develop their own, identify their own vulnerabilities, and then list their ideal actions to address those vulnerabilities. So one partnership we had recently, which was with the town of Medway in our watershed. This is one of those communities that relies on groundwater, local groundwater for their public water supply, and also has flooding concerns. So we help them do analysis of the property that they own to see where they may be able to increase some of their infiltration of stormwater. That way they're taking this water that falls from the sky, getting it into the ground to recharge their own groundwater supplies, and also reducing some of the potential causes of flooding in their community. Especially, some of that nuisance flooding that, everybody has sort of those roadways or those intersections that, flood every time we have a big rain. And what does this look like? Really, it looks like greening our landscapes. And so Dr. Danielle talked a lot about the opportunities for habitat enhancement and just restoring natural habitats. These are basically mini engineered natural habitats brought into our urban landscapes. So it provides an opportunity to catch and store runoff and just holds it until it's infiltrated. And they look nice, as you can see. One of our, sorry, fire truck driving by. One of our main climate initiatives is what we call our Charles River Climate Compact. And this is a project that we've had for the last year, and it involves bringing together all or most of the communities across the watershed to work on climate adaptation and strategies at a regional scale. Not everything can be done at the municipal scale, and not everything should be done at a municipal scale for lots of reasons, both technical and equity reasons. It really makes sense to take a lot of these questions up to a larger scale and look at them at a larger scale. In the particular case of the Charles, we have most of our most densely developed communities in the lower part of the watershed. So we need to be cognizant that we're not sending floodwaters rushing down the Charles into these communities that are quite developed and have a difficult time, will have a difficult time absorbing those impacts. So we really need to be talking about that at a watershed scale and involving folks all along the river. As far as policy and support tools, there are lots of tools out there and more tools being developed all the time. A lot of what we do is help get them into the right hands. An example is a webinar that we did actually with Crew back in May. It's still available on our website if anyone wants to check it out, where we made folks more available of some of these tools so that even if you don't feel like you're a climate scientist or really well versed in this, we still want people who are residents and active citizens and participants in their community and want to have a better community to be able to have access to understanding what are the kind of things that you can ask for, what are the kind of things that might be right for your community. So just getting activists and local folks trained and informed is also a really important piece. And then lastly, working with job training programs and supporting our youth leaders. This is not a problem with a quick fix. This is the world that generations are inheriting. And so to the extent that we can support folks that are willing to get into this field and take this on, we want to do that. And that is my quick overview. I just dropped this slide in so folks could see my contact information. But with that, I will stop and wait for the Q&A.
Thank you, Julie. That's a really interesting talk, and a lot of great projects are within the Charles River Watershed Association, and great insights into what you are doing. And thanks a lot. We do have like some questions for you, but again, in the Q&A session. So without waiting, we're gonna go to our next panelist, Melanie Gárate. She's the Climate Resiliency Project Manager for Mystic River Watershed Association. Melanie started her career as a marine scientist, where she examined how people impact climate change. Through her research projects, she was struck by disproportionate access to green spaces and environmental injustices within low-income and POC communities. Now at Mystic River, Melanie focuses on how climate change impacts people. She collectively works with local grassroots level organizations, people, health officials, and residents in the Boston area to enhance climate equity and resilience. Fellowship to study. She did a fellowship to study mangroves in Puerto Rico, and prior to Mystic River, she focused on coastal conservation and educating community members of Greater Boston area. Floor is yours, Melanie.
Thanks, Gufran. I hope everybody can see my screen. If you can't, just let me know. I really appreciate the warm welcome and everybody who has stayed on. I know we don't have too much time, and so I'll try to get through my presentation, and hopefully you'll have lots of questions afterwards. If you can stay on a little bit longer, that'd be great. And so, as Gufran said, I work for the Mystic River Watershed Association, and I'm going to switch our focus a little bit to really talk about how climate affects people, particularly the people within our watershed. And to ground us in beginning to think about that, we in the Mystic River want to make sure to honor and acknowledge the native lands that we are occupying. They are the native lands of the Wampanoag and the Massachusetts and any other tribes within this region in its past, present, and future. And if you'd like to look where you are on the map here, you can always go to native/land.ca, the Canadian website. Really interesting. And so I'll talk about really briefly, since I think we already know what's going on in terms of climate in Boston, and then focus on a couple of projects that are going on within the Mystic River, particularly a regional approach to climate resilience, as climate does not know municipal boundaries, and then specifically on our Greenways projects, which is centered around community-driven approach. And so, as we know, these are the main impacts of climate change. We're seeing lots of hot days. We're seeing a drought right now this summer, especially at Western Mass. And then we're seeing increased extreme precipitation. So lots of rainfall at one time. And then, as you know, sea level rise coming from the Atlantic Ocean, from water expansion, because the ocean is warming, and then also the melting of the polar ice caps. And I'll touch up briefly on exactly what's happening ecologically. It's very similar to what Danielle and Julie have talked about. You know, Mystic River is pretty close by to the Charles River. And so very similar things we're seeing within our river. We're seeing potential of lots of flooding. One thing that we didn't know before doing this modeling work is, if you look right here, hopefully you can see my cursor in the middle, you'll see the Amelia Earhart Dam. And that is right next to Somerville, Everett, and Malden. And we learned that if that floods because of a huge rainstorm combined with extreme sea level rise, etc., then Malden will be tidal again. And so before the dam was put in, Malden and that area used to be tidal, and this whole area that is now inhabited by people would be underwater. And that also, some of that flooding would come in from Revere, because this area used to be a salt marsh. And so also, as Danielle and Julie talked about a little bit, animals will be impacted, such as the piping plover, which makes its nest in the summertime in Revere and Winthrop, and then the salt marsh sparrows. And so and also the river herring, which go up the river ladder in this area of our watershed. And so those are some of the ecological impacts that we're seeing. But we're really, at Mystic River, we're really trying to focus on what happens to the people who live here, right? What happens to us? Climate change is happening right now. And so what makes us more vulnerable to climate change than other people? And I think that if we just think of the frame that we're in right now during this unfortunate pandemic, some people are being disproportionately affected. And so the same thing will happen with climate change, and is already happening through injustices, particularly environmental injustices. And so people are exposed differently to climate change, people are more sensitive to it, and people are not as able to adapt or bounce forward or bounce back. And these are really rooted in lots of structural inequalities that we have, systemic inequalities within our system in the United States. And so as we've been talking about at great lengths, disproportionate income, living condition, and racist systemic policies have really impacted how people can bounce forward from climate change. And so as we can see here, this is in 2018, East Boston. So if you're exposed, you know, you're more likely to feel that climate impact. If you are older or really young folks, you're more sensitive to extreme heat. And if you are wealthier, if you're able to get out of harm's way, if you're able to repair that flooding damage, if you're able to pay for that AC, then you have a greater ability to adapt to this changing climate compared to those who are working on an hourly wage, who are now our essential workers, right? And so those same people are going to be impacted and are impacted by climate change. And we have a few clues as to understand where those people are within our watershed. And so this is downtown Boston, and in the pink and orange, you can see where flooding might occur, right? And where flooding is already occurring. And there is a clue. This area, as most of us know, was filled in, and it used to be salt marshes. And so salt marshes really remember where they are. The water remembers where it used to go, and these areas are expected to be flooded, just as I showed you in the map for the Revere-Malden area. And then flood maps are not the only clue. There have been other systemic policies that have affected how people are vulnerable, particularly redlining in Boston. And so if you don't know redlining, this is a map, and this was a map created by banks supported by the government that basically drew lines where people of color and immigrants lived at that time, and deemed those areas as definitely declining in the yellow, or hazardous in the red. And those were areas where people could not get home loans or small business loans. And so how does this affect climate change? How does this affect systemic inequalities? Well, we can still see those segregated areas today, particularly in regards to extreme heat exposure. And so as you can see on the left graph, those areas that were deemed C and D, yellow and red, those were areas where people of color lived at that time. It was also Irish, Italian, and Jewish immigrants. But they've been able to have upward mobility, whereas people of color have remained within this racist system. And so it has led to areas not being developed in a positive way. Homes are not able or have not been maintained in the same way as those areas in A and B, or green and blue. And so as you can see on the map on the right, there is greater heat exposure in the lower part of our watershed because of the urban heat island effect, and then also partly because of this investment within our government in these areas. And so how can we as a watershed really move towards using policy to improve that? And so if policy was in part disproportionately affecting people of color and low-income people, how can policy now help to better that and make people more climate resilient instead of vulnerable? We started the Resilient Mystic Collaborative, which is 21 municipalities, but one watershed, kind of taking part of the a county system, because we don't really have an effective county system. And so it's a partnership within the municipalities to be able to get at climate resiliency. And so one of those projects is looking at doing a lower Mystic vulnerability assessment. So lower Mystic meaning that part below the Amelia Earhart Dam, and that part that is densely populated and also low income. And looking to protect the infrastructure, and looking at how is infrastructure, the infrastructure listed here, how do they fail if there's an extreme nor'easter? and working together with these different infrastructure folks to get at how we can better that. And then the part 2 of that work is making sure to not forget the people who live there and who might be affected if the T fails, who might be affected if the Amelia Earhart floods and then Malden becomes tidal again. People affected by the New England Produce Center where all of our food comes in. It's the main port for our fresh produce. And so those are really cost-effective ways to ensuring climate resiliency because people know where in their community it floods, how it might affect them. And I know I am out of time. I apologize. We have a few great projects in Malden looking at flood and heat resilience, adding more trees, stormwater, and getting the community involved again right from the beginning and not later on when we've already made the decisions. And so that way they have a say and then also a greater understanding of how climate impacts them in particular. And they've actually attended our Zoom meetings as well. We've gotten 80 participants at each of our public meetings, and so you know that they're invested if they're going on Zoom just like you all are, so thank you. We also have projects in Charlestown and Chelsea. So please do contact us if you want to be involved. You can count hearing, it's really helpful. They are also being affected by climate change. You can be part of our policy committee. And you can just be a really good steward and do your best to keep the area clean. As you know, everything affects everything. So thank you so much. I look forward to the discussion.
Thanks, Melanie, for the interesting talk. Great to hear what Mystic River is doing and a lot of great projects. So we are short of time for Q&A session, but we'll try to finish this Q&A session within 10 minutes. We do have some questions. First question is from Professor Paul. What does code count mean? Michael asked this question from Professor Paul.
What does what count? What does what mean again?
What does code count mean?
Sorry, I don't know where that showed up.
Michael, if you are still in the meeting, you can ask.
It was in your second to last slide. It was in a bar chart going from top to bottom, reading from left to right, increasing the width of the bar chart as it went down.
Oh, okay.
I teach at Tufts Economics. I teach environmental economics. It looks interesting, but I don't understand it.
Okay, this is the let me show my slide here. Sorry. This is this slide here, right?
That's the one. Yep.
Okay. So what was your question? What is the what do the numbers mean?
So the x-axis is labeled code count.
Oh, okay, yeah. So we did a survey of people in Eastern Massachusetts. And there's a number of people that identified, let's say, this threat. Okay, so for example, 608 people identified temperature as a major threat. 322 identified sea-level rise, and so on.
So then why do some get boxes around them and not others?
Because the one with boxes are the ones in blue, which are
so they're parameters and impacts. I see that, yeah.
Right, so we're looking at what climate change parameters people are most interested in. Those are in blue, and
Yep.
then in orange are what impacts people are most interested in.
Got
So
it.
there's some judgment here, but so for example, stormwater we consider an impact. Precipitation we considered a climate parameter.
Thank you.
Okay, sorry about the confusion.
Okay. So our next question is from Dr. Perry. The question is about are our salt marshes moving inland as the ocean rise, or just shrinking, caught between the ocean and the mainland? At what rate?
So both are happening. So one thing about Massachusetts and very popular within New England is that our coastlines are very developed. So because of that, we are seeing this squeezing happening where we're losing some of our salt marsh habitat because they just don't have anywhere to go. They want to migrate backward. That's their natural response to this type of sea level rise pressure, is just to move inland and to kind of convert some of our other natural habitats to salt marsh habitats. But because of coastal development, they're struggling to do so because of its development is just acting as a barrier for that migration. But then, as I was mentioning before, with some of our MVP action grants, what they want to do is being able to preserve more natural areas so that migration is more of an option. And so with our wildlife sanctuaries, these areas are surrounded by more of these natural habitats so that our salt marshes and our other communities, our natural communities, have room to migrate and have room to adapt as for example, as sea level rise is progressing.
Thank you, Dr. Danielle Perry. Our next question is from Julie Wood. One of our participants asked, in addition to ordinary subsidence, are we seeing any additional land subsidence due to groundwater pumping and insufficient infiltration?
Yes, ground subsidence is definitely a local issue. Yeah, so that just the other thing I would mention is, as Melanie showed in her slides, so much of our area is landfill. We just dumped, dirt or whatever we could find into wetlands and made them, buildable land, because we were getting crowded. And so, yes, subsidence is also an issue in conjunction with sea level rise.
Thank you. The next question is from Hannah Moshe, and she's talking about what is the scale we are using to consider local action in terms of our waterways. Are there lessons to be learned from other communities and room for collaboration in resiliency planning? Maybe Melanie or Julie, whoever wants to answer this question, it's open to all of you. Like, what is the scale we are using to consider local action in terms of our waterways?
Hannah, do you mind, I'm not really clear what you mean about what scale we are using to consider, like what, I'm not sure what you mean by that. Like, do you mean looking at?
Hannah, your voice is too low.
Well, I mean, yeah, I just
works with my headphone audio for some reason.
Okay.
What I'm trying to get at is, you all, first of all, are doing such amazing work in terms of kind of this very complex issue. And it's nice to see, honestly, really concrete solutions, or at least planning around kind of the effects to mitigate climate change. But what I'm wondering is, obviously, there will be variation in the local impacts of climate change, and different systems are going to react in different ways. But I'm wondering kind of what is the frame of reference you all are trying to use in your work to limit your scope and focus, and kind of, understand where you all are trying to essentially either draw boundaries, or maybe what room is there to look at other folks' work and kind of reach out to other communities that may be in a similar situation to kind of learn. Does that make sense?
I think so. So I can try to answer that for you, Hannah. Thanks. At the Mystic River, I talked a little bit about the Resilient Mystic Collaborative, and so how it's like a regional approach to climate resilience. And one project that has come out of that is focusing on those who are most impacted in the lower part of the watershed, and how we are collaborating with so many people on this. And so we're collaborating with the people who are the municipal leads on that, you know, who are directing sustainability planning, or who are directing urban planning, who know their community, as well as we're working with community-based organizations who are really on the ground right now, for example, during COVID, who also know their community and know maybe community members themselves don't understand how heat or how flooding is affecting them and how that's related to climate change, but they know how to ask the questions to get at those answers. And then also making sure to reach out and work really hard to get at those community members who are being either harmed or they are being resilient within climate resilience or social resilience in general. And so that really translates to, we're doing a lot of talking to different people, and it's taking a long time, and it's much harder to do in some ways than doing a model, right? About like, okay, this is the area that's going to be impacted. This is a map where people like Kat are going to be impacted. And so it just takes a little bit more time. And then in that way, we are actually talking to the different municipalities at the same time, because Somerville may need something different than Everett, or even, you know, East Somerville may need something different than West Somerville. And so really trying to get granular in that way.
Yeah, and maybe I should reframe when I say like local, I'm talking about maybe like outside even like Boston, talking about, you know, like looking at communities like in the Chesapeake Bay area. Mm-hmm. So that's kind of more what I was getting at. But I also understand that kind of the scale of your work is really about people. So that can definitely be challenging.
Right. Mm-hmm. Yeah, we definitely do have partnerships in Providence, for example, and areas in Arizona and New Mexico where they're facing heat in particular that is greater than ours, and we can learn from them.
Thank you. Another question from Melanie again. One of our participants says, really appreciate you all acknowledging Native groups that have stewarded this land in the past, and in what ways are those community members being brought into current conversation and solutions?
That's a really good question, and I'm glad someone asked that question. And so I've looked into the indigenous people of this area and connecting to those groups who are native to the region. And I've connected to Dr. Woods, who's an indigenous anthropologist at UMass Boston. And through talking with him and his connections, he's let me know that most of the indigenous people from here are actually elsewhere, and the indigenous people who are here are indigenous to other places. And so as I was answering the question for Hannah, we're trying to connect with those community members who are most vulnerable, including indigenous folks who are perhaps indigenous to Central America or southern, what is now United States. And so in that way, we're still trying to build those connections, but it's definitely one of the groups that we really want to make sure are included. And so we're in the process of that, but we honestly haven't made further connections because they are so spread out now.
Thank you, Melanie. We do have a question from Dr. Iram Sattar. Dr. Iram Sattar, would you mind asking your question? If you can do that.
Yes, absolutely. I'm happy to do it. Thanks very much. This was so informative. I'm actually trying to ask something that nobody addressed directly, and I'm wondering that there's been no real discussion of politics, either at the state level, because there is an upcoming primary on the 1st of September. National election, I'm sure everybody is thinking about. So we haven't really talked about how politics affects policy, which really is sometimes more than, it's not led by science, or it's not led by community level mobilizing. So I'd just like to get anybody's thoughts on how do we break through and really sort of make the seriousness of this come alive for policymakers who may be responding to different either agendas or different groups, but not in the ways that we'd like. Thanks very much.
Thank you. That was a great question. I can answer briefly what we're doing. And I probably rushed through too much in this, but we're mostly focusing on state and local political leaders. So we actually at CRWA, we have a training program that is specifically for local elected officials. Because I mean, as you've heard all of us talk about, a lot of the action on the adaptation front really is happening locally, on the local level, with communities within the municipal government. And so some of the folks that might be leading a community, though, this is not their background. And many of them, of course, also they have a job and a family probably, so they're busy. So we have a program dedicated to, we call it Resilience 101, and it's just, really quick version of what to expect from climate change, both, environmentally and human impacts. What are your residents facing? And then show them a bunch of different things that they might pursue at the local level. And then we also do work a lot on state policy. And there was actually some movement. It's been a little bit stalled at the State House in Massachusetts in recent years, but there was some movement on some climate legislation this year. So we're happy to see that, and we'll continue to push. And we work really with all the partners on the phone. We work closely with MyRWA, closely with Mass Audubon, as well as a long list of others to get those changes made at the state level. We don't delve too much into national, and I won't delve in there tonight either.
Yeah, can I add something to this?
Sure, Professor Paul, go ahead.
So in my work, we're trying to build coalitions of public and private partners, because given the capitalistic system in America, the only way you're going to get anything done is to involve the private sector in a major way, particularly in a place like Boston, where most of the land use decisions are made by private landowners and developers. So you've got to build these public-private partnerships, and you've got to make it evident to the private partners that managing climate change is in their short and long-term financial interest. And that's relatively easy to do when you just look at the past vulnerability to flooding and the way it's increasing in the future. The same thing with extreme rainfall. So again, it's the idea of building coalitions, from my perspective.
Thank you. Those are both so helpful. Yeah, it's the long, tough work, and it has to be done. So thank you for doing it.
Maybe one last question. Sharon has a question from all of our panelists. Do you serve as a clearinghouse for funding resources? He's saying my community, Nahant, has a MVP grant, but I can see a future need for additional funding.
Well, we're like all of us, we're all usually looking for funding, but we're always glad to partner with organizations, try to raise money with them together.
Yes, just to reiterate that too, if anything, maybe a clearinghouse for collaboration more than funding, so that we can kind of work together to find those pockets of money to address mutual interests for these moving projects forward.
I would agree.
Yeah, we work a lot with our partner communities to get funding. I know Nahant's right on the code, so I'm not sure what group might be the best resource to partner with there. But I mean, that is something we do a fair amount of help them write grants and get funding in the door.
Well, also, actually, at UMass, I mean, we do have a lot of students interested in this topic. So many students are doing projects for communities, being you know, under the guidance of faculty members. So in a sense, it's you know, it's support we're providing.
Okay. Another question is, like there are nowadays a lot of talks about the algal bloom, especially in the Charles River. They can see a lot of alerts on algal bloom. So while talking about the algal bloom, is it all, like you can say, natural, or a lot of anthropogenic influence in that as well?
Yes, definitely anthropogenic in that as well. Certainly the cyanobacteria are natural. You know, they're not invasive or anything like that. There's something that would be found there. But the fact that we're seeing these intense blooms every summer for these extended period of time, that's all driven by stormwater runoff pollution, excess heat, and in the case of the Charles, also the dams, which prevent really the natural flow of the water. So yes, none of that is what you would, none of the, you know, bloom impacts that we say are what you would see in a healthy flowing river system.
Okay, thanks a lot. I guess we already are out of time. It's 7:35. We hope we cover all of your questions, and I especially want to thank our participants uh, who were there with us for a long time, longer time than expected. And I hope you enjoy our discussion. And at the end, I want to thank all of our panelists, Professor Paul, Julie, Danielle, and Melanie. And you guys did a great job, and thanks a lot once again. And for our participants, we are planning to do a part 2 of the same series, maybe bringing in 2 new watersheds and some other folks who are doing climate resiliency work on grassroots level. So we're gonna keep in touch, and please do write to us, and we'll appreciate your feedback. And this event is recorded, and we're gonna publish it on our websites and social media. Thanks a lot once again, everyone. And especially I want to thank to our partners as well, UMass Boston, Charles River Watershed Association, Mass Audubon, and MyRWA, Mystic River Watershed Association. Thanks a lot. And Tufts Institute of Environment as well. Yeah, I forgot that. Thank you, everyone.
Thank you, Gufran.
Bye.
Good job, everybody.
Thanks, Gufran.
Bye.
Good night.
Good night, everyone.